Hey everybody, Vincent Ayala with Barco, here today to talk to you about processing and output creation. But first, let's check out this PowerPoint on processing. So, if you're looking to understand how the processing works and how to create your outputs, you're in the right spot. Alright, so of course we need to talk about the actual output cards before we cover this topic. We have decided to use our Gen 2 cards as well as the controllers. In the future, this information may change as we may introduce new cards and new controllers to the system. So let's check out the processing scheme inside this extremely powerful processor. It is what we call Boundless Canvas, with 8 4K60 worth of screen resources, and of course, 8 4K60 layers per screen resource, or an alternative way to look at it is 4 4K60 mix layers. And as always, we do everything 12-bit 444 processing internally with ultra low latency on our pixel perfect Athena scalers. Let's jump right into some examples by looking at this first one. Here we have a destination. It's 11,520 by 2160. It's comprised of 3 outputs at 3840 by 2160 apiece. Now, with our Boundless Canvas thought process, we can expand that canvas and separate our outputs to create canvas or mullions between the physical outputs, all represented seamlessly inside of the software. Let's take a look at this example of a pip or mix layer, or layers moving from one output to another in our canvas space. As you can see, we make sure that we make up all the time between the outputs that the layer moves, so it doesn't just jump from one output boundary to another instantly. It will respect the gap that you have between those outputs and make sure the pip travel time between the outputs is proper and accurate. Now, when we say there's always 8 4K60 layers per screen, what we mean is there's 8 4K60 split layers per screen, or 4 4K60 mix layers, because a mix layer is 2 layers bound together in an A/B mix mode. If you have used any of our other products before, this shouldn't be anything new for you. One of the things that happens when we say combine one or many physical outputs into a screen destination is by default the layers will be available anywhere on the screen by us natively creating what we call screen layers. And that requires the 4 layers from each output synced together to be available anywhere on screen. For example, if I leave output 2 and go to output 1, it's a layer from this output tied together with a layer from this output. So again, effectively what that gives you is 4 4K60 mix layers or 8 4K60 single layers on your destination, no matter how many outputs you add to it. So you're able to distribute those 4 4K60 mix layers across those outputs. Again, those are viewable anywhere on the screen destination at any time. Now, one of the ways we can achieve more layers in our destination is by utilizing split layers. Split layers are the A/B side of a mix layer split out into their own discrete layers, as such. But if you want even more layers in your destination, we give you the option to create what we call output layers. These output layers can be broken down into subregions. Those subregions can be one or many physical outputs. Once those subregions are identified, we can merge or unmerge our layers to confine them to their respective subregions. Additionally, we give you the ability to utilize split layers in conjunction with output layers. And here we see that we can have screen layers, output layers, mix layers, and single layers all active on the same destination at the same time. And to top it all off, you can adjust the states of these layers preset to preset. No need for pre-config like our older processors or some other manufacturers' current offerings. Finally, we have one last concept to really showcase the power of our processing in Encore 3, and that is stacking. Stacking is utilized when you need more layers on a destination by sacrificing one screen resource to stack it on another. You can see in this example we are going to sacrifice output 8 and give its layers to output 7. We can do this a total of 4 times, giving you the ability to create a destination with up to 16 mix layers, up to 32 single layers, or any combination you can come up with. There is one more thing to keep in mind. If your destination has more than one output and you want to stack them, you'll need the same number of screen resources to sacrifice. Example, here we have a destination that is 2 outputs. We'll need to sacrifice 2 screen resources, or outputs, to be able to stack on the original destination. Now you may be saying to yourself, well, now I only have 3 outputs. Well, that's not entirely true. You can still use those remaining outputs as multi-viewer outs, auxes, and maybe one day screen output copies. Okay, let's jump over to Event Master and work through a live demo on output creation. Okay, so here we are with Event Master Toolset version 10. We have launched Toolset, connected to a live box here in the studio, and performed a factory reset. As we talked about in the original Getting Started video, we can see some of the auto creation techniques that assist with the workflow to get you going a bit faster. One of those is creating all 8 destinations from the first 8 available outputs you have on your system. Here we have screen destinations, 1 through 8, with 4 mix layers per destination. As you can see, they have been created for me and are single output destinations. This is indicated by the number of screen destinations created, as well as the screen resource indicator here. In the following demonstration, I'm going to show you how to create screen destinations, auxes, and multi-viewer destinations with 1 or many outputs per destination. To get started, we want to delete some of these destinations. So I'll select one, any one of them, and it'll take me to the Output tab. Here, I can scroll down to the bottom where we have our screen destinations. As you can see, when I hover over them, they highlight, indicating their corresponding destination. Well, we can delete these for this demonstration, so I'll select the first or second destination and hit Delete Screen Destination. It'll ask me if I'm sure, and I'm sure, so I'll hit Delete. As you can see, that removes the screen destination. But if I wanted to go a little bit faster, what I could do is I could select the first one, and then Control A, which will select all of them, and then hit Delete Screen Destination, and then are you sure? Yes, so I'll hit Delete. As you can see, that removes the screen destinations, and the screen resource indicator is now empty. Now, I don't have any screen destinations created, so let's make some. First, I will create a single output screen destination utilizing the LED option. And for this one, I'm going to go to my Output tab, go to Screen, make sure my LED radio button is selected, and then I'm going to type in the screen name. We'll just call this Screen 1. And then we're going to go to our output connector resolution, pull the drop down, and maybe make this a UHD, and then we have our total horizontal and vertical resolution set to 3840 by 2160. Then I will select the connector I would like to use for this screen destination. So I'll drag, let's say, this display port into this box here. That's our output box. We can see our output 1 has 1 connector with a check mark, and so I'll hit Create Screen Destination. As you can see, it created that screen destination with 4 screen layers, and the destination is 3840 by 2160 at 5994, which is the screen resolution that I had asked for, as well as the system's native rate. Additionally, you can see the screen resource indicator has increased by 1. Let's move on and do a multi-output destination utilizing the LED option. Make sure we're in the Output tab. Go to the Screen tab. Make sure we have the LED radio button selected. We'll go ahead and rename our screen. And for this one, we're going to choose 1920 by 1080 as our output resolution. And we're going to have an overall wall resolution of 2496 by 960. The screen resolution is based on LED tiles that are 192 by 192 pixels arranged in a 16 by 5 orientation. If that doesn't make sense, then I urge you to seek out some training on LED wall builds. Either way, because we've typed in the total horizontal and total vertical, it's telling us to accomplish this, we're going to need 2 output connectors. So we'll select the first 2 by going here, clicking and dragging into the boxes, and there we go. We'll hit Create Screen Destination, and that created our screen destination. We'll notice that it has 2 outputs with 4 layers at 2496 by 960. If we select that destination, it'll display the settings palette. And we can see that because of our assisted workflows, we've already created the areas of interest for you. Let's take a look at the Settings tab. The settings give us the number of outputs in their dimensional arrangement. As we can see, it's 2 horizontal by 1 vertical, the format of the outputs, and our area of interest per output. If we select the first output, you'll notice it's full raster horizontal 1920, but not quite full raster vertical. It stops at 960 as requested in the wizard setup. If we select the second output, though, we scroll back down, you'll notice that the remaining 576 of the 2496 have been left up to the second output. And again, the vertical area of interest is at 960 as requested by our screen creation wizard. If we scroll down a little bit more, we can do stuff like change the HDMI connector settings, take it from 8-bit to 10-bit to 12-bit, RGB or YCBCR. We have adjustments for our color space. We can adjust it from RGB to SMPTE if we choose to. For colorimetry, we support Rec 601, Rec 709, Rec 2020, DCI P3, and so on. And then we can adjust our gamma effects. Now by default, we set it to SDR. We also allow you to use an HDR metadata file that was saved from an HDMI input. Conveniently, this is where we could trigger an HDMI 2.0 soft reset. For example, if after changing the output format the connected display did not show any signal, clicking the HDMI 2.0 soft reset button will restart the HDMI processor for each selected output in the screen destination. Furthermore, this is where you can toggle your HDCP mode and finally adjust your layer count, also known as stacking outputs. In fact, let's look at an example of stacking here. If we want to add more layers to this destination, we simply change the layer count to 8, and you'll see that in the screen resource indicator bar, the green bar has increased by 2. This is because we have a 2-output screen, and we need 2 outputs or screen resources to double the layers, as mentioned in the PowerPoint at the beginning of this video. If we come over to timing, this is where you can adjust the timing parameters of the output signal. You can adjust the color of the outputs. You can adjust the contrast, brightness, color, and gamma, hue, and saturation. And if we go over to the Wide tab, this is where we can adjust the settings that the wizard created. The screen creation wizard's LED option edge butts each output. Thus, there's no overlap between either of these 2 outputs. Basically, it's the same information we saw in the Settings tab, but here in the Wide tab, we have additional control for arranging the output's area of interest and their spatial relationship. Now, if we wanted to adjust this, this is where we could make the adjustments, like we could drag the HDMI over to the right or to the left. We could even go so far as to adjust the area of interest. Remember, if you do adjust the area of interest, it is by default a locked aspect ratio. So if you want to just make an adjustment to the horizontal and not affect the vertical, deselect the aspect ratio lock, and then inside of that you could potentially adjust the horizontal and vertical area of interest. We don't want to do that because we know that our wall again is 2496 by 960, utilizing 2 connectors, and the wizard already adjusted our AOI. So if we were to plug this into a couple of processors, you would set the first processor to 00, and then you would set the second processor to 00 as well, and the content should be displayed accurately on the wall. Alright, let's move on to a projector blend. The Projector Blend wizard is one of my favorite tools for EventMaster version 10 because it does a lot of the work for you that some screen management tools make you enter manually. So let's make sure we're in the Output tab. We'll go to the Screen tab again. We'll go down and select the Projection Radio button. Rename our blend. We'll call this one Blend. And then we'll go to our output connector resolution, let's say 1920 by 1080 again. But this time, we want to make our total horizontal 3840 by 1080 with a 600 pixel overlap. which equals 3240 by 1080. We'll type in 3240 by 1080, hit the tab button to shift over to 1080 and leave it alone. When I hit the tab button, it populates the two required output connectors. Furthermore, what it does is it auto-populates the predetermined overlap area as well. So let's see that again. So it was at 3840 by 1080, and when we enter that, it would need a 0 overlap. But we want to do a 3240 by 1080. As you can see, it automatically fills in that 600 pixel overlap again. Okay, so let's grab these two connectors. Connector 1 is for this guy, and connector 2 is for this guy. And let's hit Create Screen Destination. Now let's take a look at this blend. Let's open that contextual palette, and we can see here in the settings that everything is data doubled for us. The two outputs have an overlap of 600 pixels as requested in the wizard. Now we've seen all the settings in this before, so I'm not going to go over it again, but let's skip right to the wide tab and take a look at that. Here in the wide tab, we have our outputs in a tactical view. And let's take a quick look at this cool button up here, because this little button opens a pop-out with another window where we can, drag and drop, make adjustments, zoom in, zoom out, so on and so forth. All right, but for the sake of argument, let's just continue. So we have our overlap here of 600 pixels, which is great, and we're pretty much finished with this. Except for one thing. We've got to add the feathering to this, because most blends require feathering. At least if you choose to do the feathering inside of EventMaster Toolset. If you choose to do the feathering inside of the projector, then you're done right here, and you can move on to auxes. If you choose to feather in EventMaster Toolset, then select Feathering. And what we're going to do is we're going to select the right side of the left output, or HDMI output number 4, and the left side of the right output, also known as HDMI output number 5, and we're going to enable the feather. And for the most part, we want the feather to match the data double. The data double was 600 pixels, and then we hit Enter, and it applied the feather width. So from here, we're done. Now, if you've seen other screen management tools, you know that generally takes a few minutes to accomplish, and you must dial in all the specifications like the overlap, then sometimes even drag and drop the overlaps by themselves, but not here, not with our assisted workflows. All right, let's move on to auxiliary outputs, or auxes. For auxes, we want to be in our output tab again. We want to select our aux tab, and we want to rename it. For this output, we're going to use the resolution 3840 by 2160. And for this aux, we're actually going to select the connector in a slightly different manner. We're going to select the box, and then we're going to select the connector. Okay, so the different method there for creation isn't limited to auxes. We could have also done that on the screen destinations. You can select, or you can drag and drop. The choice is yours. So we'll hit Create Aux Destination from there. And for this one, we're going to select our aux, and we're going to take a look at our available settings. Similar to what you saw for the screen destinations, we have the AOI window, we can zoom, we could auto-configure the output if it's available. We have our format, which we can't change because this is SDI, we're limited to SMPTE formats here. So we'll scroll down. We can adjust the area of interest. This is where we have our SDI connector settings. Here's our timing tab. Again, it's locked out because we're using a connector that is SMPTE only format. Finally, here's our color tab where we can adjust the color or the contrast, the brightness, and the gamma. So let's close that because that's pretty much all we can do with auxes. Let's create a second aux. We'll rename it aux2. Let's leave it at 1920 by 1080. Let's drag and drop that connector, and we'll hit Create Aux Destination. Let's take a look at this aux again because we are using HDMI this time. We have the Settings tab where we can adjust the connector settings because we're on HDMI, HDCP, our timing tab, or our color tab, basically everything you saw for the screen destinations as well as the other aux. For multi-viewer, It's as easy as selecting an output resolution and assigning an output to that container. As a matter of fact, that's all we're going to do. Now, I know we mentioned our new output layer feature in this video, but we won't show it in detail here. We'll save that for a separate video. If you have any questions, feel free to contact us at Encore3@Barco.com. Thanks and take care.